Welcome to next session, that is second session on operational amplifiers. Before we proceed with the thumb rule and simple method, just I would like to have a recap of yesterday's things, and in that we made some small sign mistake. Instead of plus we took minus, so we will just correct that. It will be another way of revising too. So now we were talking about inverting amplifier. Just it will be recap for those who might have not understood it clearly. For those who have understood it, for them they will understand where we have gone wrong. It is very simple. I will rush through because we have discussed it earlier. So V in R1 RF VO, this is our internal voltage, means we give symbol VA and VB. So just very quick recap. The first formula of amplifier VO is equal to AD into, since it is recap, we will not skip in step, AD into VID, but VID is equal to AD into VA minus VB. In this case VA is 0, so the formula reduces to VO is equal to minus AD into VB. This is the formula for calculating output based on input difference. Now because of feedback, VB depends on VO and Vin, and as I had already stated, this is to be logically disconnected, so that you can use simple Kirchhoff's law stating that this current I1 and this current IF must be same. So we now calculate VB. We do not want VB in the final expression. Final expression we want between input and output. So this VB we calculate, which is depending on both Vin and VO, and replace that simply. So we can very easily do that. Vin minus VB upon R1, Vin minus VB upon R1, and that must be equal to VB minus VO upon RF. As already stated, we do not like denominators. So RF I multiply each term. RF V in minus RF VB is equal to R1 VB minus R1 VO. Right? What we want? We want to get rid of VB. So I take this term on right hand side, this term on left hand side, and swap the things. So R1 VB plus RF VB is equal to RF Vin plus R1, I am just rewriting, R1 VB plus RF VB is equal to RF Vin plus R1 VO. So VB is equal to R1 plus RF comes common, VB comes common and R1 plus RF remains in the bracket. So I just again rewrite, do not skip the step, is equal to RF Vin plus R1 VO upon R1 plus RF. So what is VB which we need to use in, so we want to replace this VB we do not want. So VB is equal to, just I have to make it, I wrote both steps in the single way. So it is VB is equal to RF Vin plus R1 VO upon R1 plus RF. So this is VB which is here, I do not want it in my expression. So VO is equal to minus AD into bracket RF Vin plus R1 VO upon R1 plus RF, right. And now again, as I had already stated, get rid of denominator. I derive the equation once again, so that those who might have found some gaps in understanding will find it very comfortable. So let us go step by step. This we multiply on the left hand side. So I rewrite again R1 plus RF VO, and I multiply inside minus AD RF V in minus AD R1 VO minus AD R1 VO. So what happens? Now we take this VO on left hand side. So VO into bracket, this AD R1 VO comes on this side, this R1 plus RF is as it is. So I write AD R1 plus R1 plus RF is equal to minus AD RF V in. So we want VO, this goes on the denominator on the right hand side. So VO is equal to minus AD RF V in upon AD R1 plus, just I write one more bracket for simple understanding purpose, no purpose is otherwise served. Now divide numerator and denominator by AD. So I get in the numerator minus RF V in upon R1 plus this bracket R1 plus RF upon AD, and here my purpose is over. As AD is quite large compared to R1 and RF, also this is R1 which is in some thousands, this is also in some thousands, this is in lakhs, so something in thousands plus thousands upon lakh, there is something in point, not one or so. So this is negligible, it is to be ignored, and then we get the final expression for gain of an operational amplifier working in negative feedback mode configuration called an inverting amplifier is, I write it, final expression VO is equal to minus RF upon R1 into V in. So why it is called an inverting amplifier? It is because of this minus signature. I just change the color again. So if RF is say 2 kilo ohms, R1 is 1 kilo ohm, ratio is 2 and gain is minus 2. So if V in is 2 volts, output will be minus, approximately minus 4 volts, something less than it. I hope that this clarifies the concept of inverting amplifier very clearly. So now each time, what are the conditions? Operational amplifier is to be used in feedback mode, in negative feedback, means there has to be some connection from output to inverting terminal. Positive feedback is also there and both feedbacks are also there, but our course restriction does not permit us to consider negative positive feedback right now. If time permits, we will have a small session on that, but as of now there has to be some feedback, some connection from output to inverting terminal. That is the precondition, and once that precondition is satisfied, we will establish a simple thumb rule that each time there is no need for you to start from afresh. Just like say it is exactly the same manner like derivatives. When you, what is derivative? Limit as h tends to 0, f of x plus h minus fx upon h. But each time you don't do that. So you, using that, you prepare some formulae which you use for further calculations. So like that we will develop some formulae for calculations, and based on that we will discuss some circuits. The meanings of the circuits I will write first so that you can have some guess, and we will proceed further. So each time, as I had already stated, there is no need to calculate everything once again, this AD and then dividing by AD, then saying that it is very small, so ignore. So assuming this AD is very large, assuming that op-amp draws no current, there is simple formula which I will tell, thumb rule. How to deal with an operational amplifier? I write thumb rule to deal with I write on the left hand side, on the right hand side I will take an application to deal with op-amp with negative, that is very important. I again write, I purposefully make the sign with different color, negative feedback. Otherwise this is not useful. This is thumb rule. So what do we do? Any circuit we can have. This is we call is as VB, this we call V as VA, that is internal voltages. This is non-inverting terminal, this is inverting terminal. Why? Because that we did not mention actually, it is obvious. Why it is called a non-inverting terminal? Because op-amp gain is based on difference. So VO is AD times VID. In calculation of VID, VID is VA minus VB. So from voltage of this terminal you subtract this terminal. So it is non-inverting, this is inverting. Now whenever there is some connection, we can draw some any complex circuit we can have, absolutely, or rather we will go through a very general circuit. It does not have any application, it is simple op-amp circuit with feedback. We will calculate the output. So you can have any kind of arrangement. So let us have a simple arrangement. We don't derive any formula, we take actual values so as to make it things simpler. This is not any specific circuit. How to find the output? So you can find the output based on the method which we discussed in the last lecture and we just revised in the current lecture. However, each time as there is no point in calculating derivative by first principle, I now tell you thumb rule, set of thumb rules. Rule number 1. This is thumb rule. Don't quote it anywhere. It is not something like standardized rules. It is non-standardized, just like if we think of anyway it is a word which is to be taken with pride or some kind of guilt, depends upon how do you interpret, just like a jugaad technology which is being uttered about. So the first rule, disconnect op-amp input terminals logically. Op-amp input terminals logically is important. Logically means in your mind. Actually there is no disconnection, because if there is disconnection, op-amp will not, system will not work. So the purpose of this disconnection is to ensure that what is the end outcome for which we calculate using this, op-amp terminals don't draw any current. In fact, they draw negligible current which we ignore. Op-amp terminals do not draw any current. So you can use Kirchhoff's law very easily at inverting amplifier, inverting terminal node, first rule. Then second rule, calculate the voltage at non-inverting terminal independently, because in this case there is no feedback for non-inverting terminal. Right now we don't go for positive feedback. So in case of non-inverting terminal, there is no connection of output. So based on other circuit which is there, which is coming to this point VA, you calculate VA independently. So I write calculate non-inverting voltage, non-inverting terminal voltage VA. VA, I'm using that symbol VA. Then third rule, which is very important now. Third rule, just transfer this to inverting terminal. It is a thumb rule. Don't ask why right now. Transfer non-invert, I am writing very specifically so that there is no, since it is now in offline mode, I cannot assume whether you have understood or not, so I have to be very specific and clear. Non-inverting terminal voltage to inverting terminal means what exactly you have to do? Whatever is told by this long sentence, I tell it in a single statement, that is, have VB equal to VA, that's all. So disconnect op-amp terminals, calculate VA, have VB equal to VA, have VB equal to VA, right? That's very simple. Then fourth I write here so that you can see all simultaneously. Fourth rule, calculate VO by using ohms, because ohm will be angry, ohms and Kirchhoff's laws. Calculate VO by using ohms and Kirchhoff's laws around inverting terminal node. It is important. Around inverting terminal node. That's all. These are the 4 thumb rules based on which I am very much sure that anybody, even a high school student, should be in a position to calculate VO. So we calculate it for this right now. So I rub this, use the space above so that you can see thumb rules and you can also calculate everything. We try to optimize the board space. First of all, disconnect op-amp input terminals logically. Since the disconnection, you can do it very easily because it is very easy to break. Instead of making, you can do it very simply. So first step doesn't require any efforts as such. Then, then second, calculate non-inverting terminal voltage VA. How do you calculate? Simple potential divider, 3 volts, 2K, 1K. So ratio is 1/3. This is ground. So obviously VA will be equal to, I write here itself, VA is equal to 1 upon 1 plus 2, that is 1/3, or VA is 1/3 into 3. So VA is 1 volt. So I write VA equal to 1 volt here. VA equal to 1 volt. After I write VA equal to 1 volt, what we are required to do? We are required to take, remember this is logical disconnection, then somebody will say, oh, how you can say, if this is VA, how you can say this is VA? It is just to ensure that current doesn't flow, otherwise it's very well connected. The disconnection is from your mind and not actual disconnection. Then transfer this 1 volt at inverting terminal, 1 volt. And now by Ohm's and Kirchhoff's laws, calculate VO. How? Just look at this. This is the most crucial node in the entire system because feedback comes here. Then this is I1 from this to this, and this is IF. Or now there is no need to calculate these things. We can say this is I, same is this I. The current should be same because this terminal doesn't draw any current. Current incoming equal to current outgoing. So this, what is this current? 2 volt minus 1 volt. I can write a simple equation. 2 volt minus 1 volt upon 1000. Why 1000? 1 kilo ohm is equal to 1 volt minus VO upon 1000. 1000 disappears. So 2 minus 1, that is 1 is equal to 1 minus VO. 1 is equal to 1 minus VO. Is it right? 1 is equal to 1 minus VO. So what is VO? VO is 0. So 0 answer has come. It can come as an answer. We should not be allergic about that answer. So in this case, VO is equal to 0. But if such answer comes at initial phase, then somebody may say whether I have gone something wrong. In order to ensure that this is not like that, what we have to do is just instead of this 2 volt, make it 4 volts and we can have rework. So in that case, nothing will change. Everything, this will remain same, this will remain same. This I will make 4 volts. This I will make 4 volts. So this will be 3. 3 is equal to 1 minus VO. So VO comes on this side. 3 goes on this side. VO would be minus 2 volts. VO will be minus 2 volts. I hope it is quite clear. Now we can have some small changes in the circuit components, and I hope now I can rub this out. The steps are very simple and I hope that everybody must have done them by heart. We will change some values, and after changing some values we will calculate voltages so that it will give you a rigorous exercise. So with these rules, I think that everything you can calculate without any exception as such. So we make small changes, we make it 5 kilo ohm, we make it 5 kilo ohm, and we make it 3 volts, and just this we keep same so that not much changes are required to be done. So in that case, first step disconnection, second step calculation of VA, third step transferring VA to VB remains common. Then we simply take fourth step, apply Ohm's and Kirchhoff's laws at inverting terminal node. So 3 minus 1 upon 1000 is equal to 1 minus VO upon 5000. 1 minus VO upon 5000. 5 kilo ohms, we are using 5000. So obviously 1000 goes, 5 remains there, and so I can say 2 is equal to 1 minus VO upon 5, right? That these things go, these things go. A simple school level calculation. So 5 comes on this side. So 10 is equal to 1 minus VO. 10 is equal to 1 minus VO. So what is VO? VO comes on this side, 10 goes on this side. VO is equal to minus 9. VO is equal to minus 9. I hope this is same circuit with some change in either resistance values or voltages. Now I make a further change. Instead of this 3 volts, I will make it 5 volts, and let us see what happens. If it is 5, this becomes 5, this becomes 4, this becomes 20, and this becomes minus 19 volts. And here now the answer is something which makes us to rethink on everything. Why? Because op-amp cannot give, we assume that supply is plus minus 15. So op-amp cannot give voltage more than supply voltage. So this is something which is not possible. I scratched it. I wrote and scratched, indicating it is not possible. Then what? Now, up till now, I have stated only 4 thumb rules. Now there is a need to specify 5th thumb rule. What is that 5th thumb rule? I think you can imagine what the 5th thumb rule would be. 5th thumb rule is if calculated VO by U is in between plus minus 15, I am assuming that supply is 15 volts. If it is between plus minus 15 volts, everything you have done is correct. Your solving of example is complete. You go for next question in your question paper if it is exam time, right? So if minus 15 less than equal to VO less than equal to plus 15 means if VO is in between plus and minus 15, everything is right, or instead of writing answer is correct. Answer is correct. But if, we can write 6, but if not, then 6 will come. Means if not means what? If either voltage is less than minus 15 or more than plus 15. So what's 6th rule? Either if VO is less than minus 15 volt, make it minus 15 volt. If VO is less than minus 15, make it minus 15, that is 6A we can say, or what 6B, if VO is greater than plus 15, make it plus 15. Make it plus 15. So if answer comes within the limits, everything is correct. If not, VO needs to be changed. Now what will happen with VB? What will happen with VB in this case? In this case, this is 5 volt, this is 3 volt. Output should have been minus 19, but it is minus 15. So in that case, our assumption in step 3, transferring this to this is called as virtual short concept. Means when op amp is in negative feedback, voltage of inverting terminal is approximately equal to non-inverting terminal. This is called a virtual short. Both are approximately equal. But that is valid if and only if output computed is within the window of plus minus 15. If output computed goes beyond the window and you restrict it to window, in that case your assumption of VA equal to VB is wrong, and this thumb rule 7, if is recalculate VB. Earlier what you did? You assumed VB, calculated VO. You assumed VB, calculated VO. Now since calculated VO on assuming VB to be equal to VA is wrong, you have changed VO to be ceiling limit. So calculate VB based on what? Based on Ohm's and Kirchhoff's laws, because you know this voltage you know based on, I can say, known or instead of given voltages and VO, which is either plus 15 or minus 15 as the case may be, with or using Ohm's and Kirchhoff's laws at inverting terminal, at inverting terminal. I think this can be seen. It is seen properly, this color also. Okay. So, VO is now not minus 19 but minus 15. So, how we calculate? So, what is wrong? This is wrong. This is now minus 15. Then you recalculate phi u, same logic, phi u minus VB upon 1000 is equal to VB minus, I write minus 15 upon 5000. So, phi minus VB, this 1000 triple zeros go, phi u multiply on this side, 20 phi u minus phi u VB is equal to VB plus 15. So, which leads to very simple, this 5 VB comes on this side, 6 VB, this 15 comes on this side, that is 10 equal to 6 VB. Just give attention, this 5 VB goes on this side, 15 comes on this side. So, 25 minus 15, that is 10 is equal to 6 VB. So, VB is equal to 10 by 6 or 5 by 3. So, non-inverting 1 volt, inverting 5 by 3 volts, output is minus 15 volts. So, with this you can absolutely find out any circuit, find out the output for any circuit which uses negative feedback, The last step, that is this 5th, 6th and 7th rules are to be used only if the means if 5th rule is satisfied, 6th, 7th are not required to be used. So, after using 4 rules, you just verify whether output is within the window or not. So, now we take examples using this. Any general circuit also we can have, but now we will go for examples in our syllabus, because right now because of the scenario it does not allow us a big luxury to discuss things in detail, but once I finish the contents which are required in the syllabus, then we will specifically deal with the lectures beyond syllabus, but that should not be the priority at this stage. We will first finish something which is there in the syllabus. So, now the circuit which we are discussing, name of the circuit is inverting adder. To be very precise, it can be scalar also, but if things are equal, it becomes adder, scalar or scalar amplifier also. I will explain everything, and when things are equal, it becomes adder. So, this scalar amplifier right now this means it is required, but right now not required. So, written and scratched. So, at initial stage you focus on inverting and adder, that is the name, but it will come through this. So, main thing is inverting adder, but it comes through this. So, we draw the simple circuit. This is always VA and VB, these are crux. This we have taken 3, but it can be anything. Non-inverting is grounded. This is V1, V2, V3. 3 RF, R1, R2 and R3. Now calculate the output. This is most simple because first I think now there is no need to say about first step, that is disconnection of op amps is logical, just like a question whether you have taken your food. So do not ask every time. So we go from the second step. Calculate voltage non-inverting. Here there is no need of calculating, it is directly grounded. So VO is 0, VB transfer to inverting 0, this is disconnected, no current does not flow. Now simply apply Ohm's and Kirchhoff's laws at the inverting terminal. So this is I1, this is I2, this is I3 and this is IF. So simple, nothing to specifically write. IF is equal to I1 plus I2 plus I3, that is Kirchhoff's law at inverting terminal, and each current is to be found by Ohm's law. So what is IF? IF is 0 minus VO, IF is 0 minus VO upon RF is equal to, what is I1? I think there is no need now, it is quite simple and obvious. I1 is V1 upon R1 plus V2 upon R2 plus V3 upon R3. So the 0 minus VO, the minus RF goes on this side. So because you want VO expression of VO, VO is equal to minus into bracket, or we can say minus RF into bracket, or we can write again RF upon R1 V1, or we can write separately like this, it does not matter much, minus RF into bracket V1 by R1 plus V2 by R2 plus V3 by R3, means each it is weighted sum of 3 voltages, VO and inverting, weighted sum. So V1 gets multiplied by minus RF upon R1, V2 gets multiplied by minus RF upon R2, V3 gets multiplied by minus RF upon R3. So it is weighted sum. But if R1 equal to R2 equal to R3 equal to R, if we have if R1 equal to R2 equal to R3 equal to R, then it becomes simple equation, VO is equal to minus RF upon R into V1 plus V2 plus V3. So the scaling goes, it is addition and amplifying, addition and amplifying. So general expression, VO is equal to minus RF into bracket V1 upon R1 plus V2 upon R2 plus V3 upon R3. So the voltages are multiplied by some constants. Now if further RF is also equal to R, in that case we get the last expression, that is most important expression, VO is equal to minus into bracket V1 plus V2 plus V3. It is adder, and why inverting? I just change the color of this sign. Why it is? Because it is minus. VO is equal to minus into bracket V1 plus V2 plus V3. So this is inverting adder. If V1 is 1 volt, V2 is 2 volt, V3 is 3 volt, output will be minus 6 volt. If V1 is 6 volt, V2 is 7 volt, V3 is 8 volt, then VO would be minus 21 volt. It can't happen. So VO would be minus 15 volt. So all applications which we discuss here are considered to be assuming that output will come in plus minus 15. If it does not come, then it gets restricted and that application does not serve the purpose, that is the result is not as per, means in that case it is not an adder. If 5, 6 and 7, it should be minus 18, but it will come as minus 15. In that case, it is not an adder. So, the op-amp circuitries operate properly or operate as per their meaning if output is coming within the window. Now, we go for a non-inverting adder. We go for a non-inverting adder. Actually, in non-inverting adder, addition takes place outside op-amp. Op-amp does not have much role there, just we will have a simple expression for it. I will have a non-inverting adder. Now, here we do not take values, that is the resistance terminals, we do not take different because it will unnecessarily complicate. We just want to give you one simple formula for addition. So, these values also we take R and R, so that things become simple, and based on that, if we calculate and if some addition is not taking place, we will just readjust the values. So, now again same thing, VA and VB. What is VA? Now, here VA is to be calculated based on V1, V2 and this. So, it has no role of op-amp, it is simple potential divider like circuit, simple what we can say Ohm-Kirchhoff's law thing. So, what is V? Op-amp is not coming into picture at all because there is a disconnection. So, how to calculate VA? VA is to be calculated by V1 minus VA upon R is equal to, if you assume this current I, same must flow here like this, because it does not flow here. So, V1 minus VA upon R is equal to VA minus V2 upon R. So, by applying Kirchhoff's law, V1 minus VA upon R is equal to VA minus V2 upon R. Current assumed in this direction is equal to VA minus V2 upon R. So, R gets cancelled, this VA goes on this side, this V2 comes on this side. So, VA is equal to V1 plus V2 by 2. So, here addition has taken place actually. VA is V1 plus V2 by 2. Now, transfer it to VB. Transfer it to VB. So, VB is V1 plus V2 upon 2. Then apply Kirchhoff's laws. Now, you find this as ground. So, you conventional thing current is in this direction, no problem. If you take reverse direction, value will come negative. So, applying Kirchhoff's law at this node, VB minus 0 upon R. What is VB? VB is V1 plus V2, or with this it has become a non-inverting amplifier whose gain is 1 plus RF upon R1. So, this is V1 by V2, this is R, this is R. So, it is 1, R upon R is 1, 1 plus RF upon R, that is it is 2, V1 plus V2 by 2 is input, gain is 2, output is V1 plus V2. We can derive separately also. V1 plus V2 upon 2 minus 0 upon R is equal to V1 plus V2 upon 2 minus VO upon R. So, R gets cancelled, R gets oh, we made a mistake, we have assumed this direction current. So, it is VO minus V1 plus V2 upon 2. So, R gets cancelled. When R gets cancelled, the equation becomes simple. V1 plus V2 by 2 is equal to VO minus V1 plus V2 by 2. So, it comes on this side, V1 plus V2 by 2 plus V1 plus V2 by 2. So, VO is equal to V1 plus V2. So, it is called as non-inverting adder. It gives direct addition. It gives direct addition. It is called as non-inverting adder. We can have some gain also if we make this value different. In that case, there would be some gain. It is called as summing amplifier. But okay, for summing amplifier also we can have some values. So, this is inverting adder. Suppose if I make this value as KR, in that case things will change. There is one more way to, so here we calculate this output. Otherwise, how you can calculate? There is simple way. You have calculated VA. You have calculated VA. So, once you have calculated VA, you can rub this out and say that this is V1 plus V2 upon 2. Then this combination which we have already discussed, this is non-inverting amplifier. You apply input at non-inverting terminal and have some RF and have some R1. RF here, R1 here. So, what will be the output? It is now this adder is just like a non-inverting amplifier. So, what you can have? You can have VO is equal to, by formula, 1 plus RF upon R1 into V in. But what is V in? That is equal to, VO is equal to 1 plus RF upon R1 upon 2 into bracket V1 plus V2. So, this becomes summing amplifier. This becomes summing amplifier. In previous circuit also, if RF was not equal to R, it becomes not adder but summing amplifier in inverting mode. Here it is summing amplifier in non-inverting mode. Suppose if you take RF equal to 5, R1 equal to 1, RF has 5 kilo ohms, R1 has 1 kilo ohm, RF by R1 is 5, 1 plus 5 is 6 upon 2, 3. So, if you take RF is equal to 5 R1, in that case VO is equal to 1 plus 5, that is 6 by 3 into bracket V1 plus V2. It becomes summing amplifier. And if summing amplifier, if RF equal to R1, this becomes 1 plus 1 upon 2. In that case, VO is V1 plus V2, it is adder. Summing amplifier with gain 1 is adder. Now, I hope actually there is no need to explain everything, but it is there in the syllabus and you are in the first year, every circuit needs to be discussed. So, we will be ending today's session with the last part, that is difference amplifier. And difference amplifier is also called a subtractor if gain is 1. So, the title is difference amplifier. Or subtractor. In fact, if it have been normal days, it would have been given as an assignment in the class to be completed by you, but right now that live thing we can't have. So we just, there is no scope for you to think, but you can think independently. You don't look at the further thing, you try to design on your own and then go for watching further video. This always you need to write, that is our crux, that is VA, VB. This is VO. Again, everything is same. What is V? Disconnect op-amp terminals, that need not be told. What is VA? VA is equal to RF upon RF plus R1 into V1. VA is equal to RF upon RF plus R1 into V1. Now transfer this here, means VB equal to this. But if you transfer it right now, the things become lengthy for calculation. So what do we do? Based on this, based on Ohm's and Kirchhoff's law, we calculate VO. VO will be in terms of VB. By applying Ohm's and Kirchhoff's laws at this node, we calculate VO first. VO will be in terms of VB and we put VB equal to VA. So just we alter the sequence so as to things become simpler. So what is V2 minus VB upon R1 is equal to VB minus VO upon RF. That is quite clear. Obviously, Ohm's law, current, this current I1, this current IF. V2 minus VB upon R1 is equal to VB minus VO upon RF. Cross multiply. So RF V2 minus RF VB is equal to R1 VB minus R1 VO. Now take it on this side, take it on this side. So R1 VO is equal to, take everything on the other side. What is that? R1 VB plus RF VB. So RF plus R1 VB, and this goes minus RF V2. And now this is now, if we have put this here, the calculation would have become lengthy. Now what you do? Now you put value of VB equal to VA. VB equal to VA. So putting VB equal to VA, it becomes very simple. Here it is in numerator, it is in the denominator. So if the same expression I write, R1 VO is equal to RF plus R1 into RF upon RF plus R1 V1 is RF, or I write so that there is no rush through, RF plus R1 into VB is RF upon RF plus R1 into V1 minus RF V2. Minus RF V2. And one more thing, this is R1 VO. Now I simply scratch this. So R1 VO is equal to RF V1 minus RF V2. Now I can take common, it becomes very simple now, nothing to explain. So that gives rise to R1 VO is equal to RF into bracket V1 minus V2. That gives rise to VO is equal to RF upon R1 into V1 minus V2. So I rewrite the expression here. since it is recorded, even if I rub it out, you can go back and see. So, that is not a problem now. So, VO is equal to a constant for given circuit into difference of voltages. So, it is difference and it is amplifier. I hope everything is now very clear. Difference V1 minus V2 amplifier. And if RF equal to R1, then VO is equal to, both are equal, let RF be equal to R1 be equal to R, that is not important, V1 minus V2. And in that case, it is subtractor. If values are equal, it becomes subtractor. So, today we discussed thumb rule to calculate things, then different general applications and specific applications like summing amplifier or adder both in inverting and non-inverting mode, then difference amplifier or subtractor. One thing is to be kept in mind, all these circuits use negative feedback, and the circuits using negative feedback will give the correct result provided that is the result, that is the output VO is in between plus 15 to minus 15. If it is not, things will go wrong and you have to recalculate everything by sealing voltage to plus 15 or minus 15. In the next lecture, we will take some general examples based on negative feedback, 2-3 that is the trial examples, and there is something called as properties of an ideal amplifier that we will discuss. So, this is somewhat theoretical, some explanation needed. I will just list the properties so that the module is complete at least at a preliminary stage, considering all points in the syllabus. So, if time permits, we will go for some further points beyond syllabus later on. So, in the next lecture, we will go for various examples considering all options, considering the situations where output is between plus minus 15 or sometimes it goes beyond plus minus 15, then recalculating it to plus or minus 15 and working back the inverting terminal potential and some ideal characteristics of operational amplifier. I think we stop for this session.